Okay, so today we're going to start calculating with the conservation of momentum and collisions. And so I'm going to share my screen and walk you through a couple of the calculations and give you time to do a few as well. Okay. All right, so I'm going to share my screen so that we can look at this together. And I'm also going to turn off my video here. And open up my hover cam. Okay. Here, set up. All right. All right, so with calculations, the key thing to remember is that the total momentum before the collision is equal to the total momentum after the collision. And that's what conservation is, the momentum conservation law is all about. Basically, when these cars collide or when your carts collided in yesterday's lab, the momentum just transferred from one to the other. And so total momentum before always equals total momentum after. Okay, so total momentum before, then they collide, and it equals total momentum after the collision. Okay, and so what happens is you can solve for the total momentum before the collision, and then that should equal the total momentum afterwards. And also there will usually be a missing value that you're searching for. Okay, so let's try this. All right, so these car A and car B are traveling towards each other. It doesn't look like it because B is facing to the right, but if you look at its arrow, it's pointing to the left. And so one key thing also to look at as well is because it's to the left, this is going to be a negative number. So that velocity is negative because it's to the left. Okay, so car A. Its momentum, which remember momentum is mass times velocity, is 1,000 times its velocity, which is 10. So its car A's momentum before the collision is 10,000 kgms. Car B has a momentum of mass times velocity, because that's how we find momentum, 2,000 times its velocity, -2. And so its momentum is -4,000. Okay, so we know the total momentum before the collision would just be the sum of those two momentums. So the total momentum before the collision is 6,000 kilogram meters per second. Okay, that's going to equal our total momentum after they collide. So what we can do is we can set it equal to the total momentum of each car after they collide, because they bounce apart or they stick together, whatever happens. And so what is missing is the velocity that car A is going after the collision, but we can try and solve for that. So let's say car A, it's new momentum, or mass times velocity, so 1,000, and we're looking for his velocity after they collide. Car B, after the collision, is a mass of 2,000, and its new velocity after it collides is +4. So its momentum after the collision is 8,000. And so the total momentum before the collision was 6,000, this number right here, remember? So whatever this adds up to be, it's going to have to be equal to 6,000. And so 8,000 plus what will give you 6,000? Negative 2,000. So what does this unknown have to be in order for this to equal out to 6,000? Negative 2. So that's your unknown. That's your answer. That's what we're looking for. So negative 2,000 plus 8,000, and you'll get 6,000 kg. S. And so total momentum before was 6,000 and total momentum afterwards was 6,000. But to answer what they're looking for the velocity of car A after it collides, and it was negative 2. That was the unknown. That was what it had to be in order to equal out to 6,000 like it was before the collision. So here your answer is negative 2 meters per second. That was the velocity of the car after they collided.